This is Year 13 AS2 Physics 2, and these are sound past paper questions, and they have originally come from both AS2 and AS3 before. So this is the first question, and this comes from AS3 Physics 3 2001. What is meant by the intensity of sound at a point? So the intensity of sound at a point is given by the power per unit area, or power per unit area. Now, if you're not going to write a sentence like power per unit area, that's okay, but you must write down the letters of an equation. So you must write the words, sorry, not the letters, the words. So it's power over area. And you could also give the units if you wanted. And that's 2 marks. The next question. The performer on the stage of an outdoor concert may be considered as a point source of sound, radiating sound energy uniformly in all directions. I'm just scanning a wee bit there. The sound intensity I at a point at a distance d from this source varies with distance according to an inverse square law. That is that I is equal to power over 4 pi d squared, where d is the distance away from the source. Now the idea is that the source radiates uniformly in all directions, i.e. over the surface of a sphere, and this gives you the surface area of a sphere, 4 pi d squared. So on figure 3.1, sketch a graph of the variation of sound intensity I with distance d represented by the equation 3.1. Now you can see from that equation that I is proportional to, if power and 4 pi are constant, 1 over d squared. So therefore this is going to be what we call an inverse square law graph. And if we're going to plot I and d on the 2 axes, that means that d squared, but it's 1 over, and so it's going to be a downward sloping curve, a fairly steep downward sloping curve like that. And this would be a fairly normal kind of, or a very often asked question about the inverse square law, about the relationship between I and d, and it's a graph which goes down like that. The source has a sound power, this is part 2, sound power of 0.28 watts. Sound X is 15 metres from the source. Calculate the sound intensity at I. So you're just using that equation. I is equal to P over 4 pi d squared. And P is 0.28. And D is 15 metres, and it's the 15 is squared. And when you put that in your calculator, that comes out as 9.9 by 10 to the minus 5. Now you do expect very small values for a lot of the sounds that you hear. If you know, or if you remember your intensity curve for the ear can hear from 10 to the minus 12 watts per metre squared up to 10 to the 2. And so, you know, you would expect a small number there. And that's something that you should be looking out for. Calculate the sound intensity level at X. So I'm going to write that equation as IL as an intensity level. And it's 10 times log to the base 10 of the intensity at X over that threshold intensity, which is at 1 by 10 to the minus 12, the quietest sound that you can hear. And when you put those numbers in, you get 10 times log to the base 10 of 9.9 by 10 to the minus 5 divided by 10 to the minus 12, or 1 by 10 to the minus 12. And that comes out as 79.95 decibels. And given that we have only got 2 significant figures, we're going to round that up to 80 decibels. So we have 2 significant figures in this number. Sorry, I pointed up here and I didn't show you that. There's 2 significant figures in that number, 2 significant figures in that number. So we're going to round our answer to 2 significant figures up to 80. Part 3. Sound from the source is now amplified electronically on stage. This increases the sound intensity level at X by 4 decibels from the value obtained into part 2. Calculate the corresponding factor by which the sound intensity at X is increased. So what we have to do is use this equation backwards and work out how much the sound intensity has increased to, and then work out the corresponding factor. And so the first thing we're going to do is our new intensity level is 84. And so if we need to calculate a value for I for this 84, we have to work backwards from our equation. So there's the equation, intensity level equals 10 log to the base 10 I over I naught. We need an equation for I, so we have to divide our intensity level by 10, take the inverse log of it, and then multiply it by I naught, and that will give us I. So that's the equation rearranged. So just working backwards again, intensity level divided by 10, take the inverse log of it, and then multiply it by I naught will get us our value for I, and that's still not our answer. So I is equal to then 10 to the minus 12 log to the base to the minus 1 of the intensity level is 84 now over 10. So that's our new intensity level, and it comes out as 2.5 by 10 to the minus 4. So then we want to work out what is that compared to what it was before, and it was 9.9 by 10 to the minus 5 before. So the factor that it has increased by, we're just going to divide the 2.5 by 10 to the minus 4 divided by 9.9 by 10 to the minus 5, and that comes out as 2.5 to 2 decimal places. So the factor that it has increased by is 2.5.